So I'll begin with a quick recap on service meshes for anyone who's just joining us. Here is a simple model showing how two microservices might typically communicate with each other. There's an API service that will discover and dial the IP address of a backend service. In a service mesh, the key change is that a sidecar proxy is deployed alongside every service instance. Services no longer dial each other directly, but rather do so through their proxy over localhost. Now the network's been abstracted away from the API itself, and the proxy can take care of complex routing logic, such as discovering and load balancing between instances of the backend, encrypting outbound communications, retrying on 500 errors, and a lot more. And authorization in Consul between these two services is driven by the feature we call intentions. Sidecar proxies at the destination service authorize or reject inbound connections based on the intentions that reference their identity and the identity of the caller. The important thing to note here is that intentions don't reference IP addresses, only service names, and they apply to all instances of the services that are referenced by the intention. Now, this might be the most common question we get when we speak about Consul service mesh. And I'd like to talk about some of the recent features that we've released to address it. Today, I'm going to talk about two new gateways at the edge of the service mesh that enable traffic to flow in and out. And then I'm going to go through a demo to show them in action. So going back to the service mesh model that I showed earlier, this model is super smooth and awesome when both services can be deployed with sidecar proxies and do not have external dependencies. But what happens when you need to call out to a service where you can't deploy a sidecar? What if our backend needs to make a call to a managed cloud service? Or what if it needs to make a call to services that we manage but haven't deployed a proxy alongside of? There's also the question of how do you allow others to consume workloads inside of a service mesh? If a pioneering team deploys its services onto a mesh, we need to ensure that other teams can still integrate with them. So let's take a step back and answer these both one by one. The first task mostly boils down to enabling traffic from services with sidecar proxies to services without them. New in Consul 1.8 are terminating gateways. Terminating gateways enable your greenfield applications in a service mesh to integrate with existing infrastructure. As with a transition to the cloud, a transition to a service mesh will likely not upgrade all services at the same time. Organizational and technical constraints may keep services from upgrading to a mesh, but applications that do get upgraded will still depend on them. By having these single points of egress from the service mesh, you can easily secure access to external resources from a limited number of gateway nodes. This is particularly valuable when controlling egress from an environment with ephemeral addresses like Kubernetes. With terminating gateways, intentions will authorize connections from ephemeral services to the gateway, and then your firewall has the much simpler task of securing access from known gateway nodes to the final destination. One key feature of terminating gateways is that a single gateway can route to one or multiple services outside the mesh. You will decide what subset of services you want to expose through the gateway. The next task we wanted to solve was accepting traffic from services outside the mesh. Also new in Consul 1.8 are Ingress Gateways. Ingress Gateways allow inbound access into your service mesh. They can also take advantage of native capabilities of the mesh, like HTTP-based routing. Using Consul's L7 configuration, Ingress Gateways can route to a destination service based on attributes like the path and the headers of a request. Ingress Gateways are a unified way to ingress into the mesh, regardless of whether you're on Kubernetes or on virtual machines. They allow us to accept traffic, which is then encrypted at the gateway with TLS. They can also listen on a single port or multiple ports and can route to one or multiple services. Once again, you decide what subset of services you want to expose through the gateway and how. Next, I want to show you what it's like to get these up and running. This is the setup that we're going to be working with. You can see that we have a Kubernetes cluster on GCP. The web API and cache services are already in our service mesh and communicate with each other through a sidecar proxy. What we want to do is improve the inbound access to web and the outbound access to DB. So now I will switch to the demo. Go away. Great. So this is the UI for our web service, and it actually shows the call graph for its dependencies. We have the web service, which is dialing the API through its proxy, and we can see that because this address right here is the address that web is dialing. So it is reaching the API via localhost 9092, and then the API is reaching the cache via localhost 9093. And for the database, which is not going through a proxy, it's reaching out directly at a hard-coded IP address. We also have the Consul UI, which shows everything is registered. And to start, I'm going to show the configuration that I'm using for Consul on Kubernetes. So I have this GKE data center using the latest version of Consul, the latest supported version of Envoy. We have connect inject enabled, which is going to attach proxies to the pods that you deploy. And we have the UI exposed as a load balancer so I can access it from my local machine. The first thing we're going to do is enable traffic from the API to the database to go through the mesh. And we are going to do that with a terminating gateway. This shows the additional configuration that we need. There's going to be a new terminating gateway stanza. We're going to enable them, and we're going to leave all the other defaults as they are. Then we're going to upgrade the install, and this is going to take a little moment, and the gateway should appear on the right momentarily after it's been deployed. So after the terminating gateway comes around, another thing that Consul needs to become aware of is the database service that it's going to route to. Here we see the gateway coming up. Its health check's currently failing, but it'll pass soon. So then for the database service, I have this minimal service registration. It places it in this data center that we're in. We define a node and an address for that node and some very basic metadata like the port that that service is going to be reached in and its name. Now we can go ahead and register this directly in the catalog. And the next step that we need to consider is that the database is registered, but we still need to tell the terminating gateway that it needs to route to it. And the way that we handle the configuration for gateways is with something that we call configuration entries. This is an example of a terminating gateways entry. It references the kind. So this is a configuration entry for a terminating gateway. The name, we're just using the default name here, but it could have a different service name if you choose. And this is going to be the names of the services that it routes to. So by associating the name of the gateway to the name of the destination, now anytime that you spin up additional replicas of the gateway or additional replicas of the database, Consul will just take care of that and handle that based on the routing based on the name. Then we can apply this with Consul config write. Whoops. One moment. Over here. And now we see that the database is a linked service to the gateway. But we still haven't updated how the API dials that upstream. So I'm going to do that next. And actually, before that, another thing that we need to handle is once the traffic is going through the mesh, it also gets governed by intentions. So now we're going to need an intention that says the API can talk to the database. I'll add that real quick. And now I'm going to do the update to the API service. So this is what that service definition looks like. The only bits that are really important are down here. So these two annotations are how, so the first one is determining that we need to inject a proxy sidecar into this pod. And the second one determines what upstream services the API is going to call and at what port it's going to reach them. So right now it only has the cache on 9093. And that means that it can access it via localhost 9093. And what we need to do is add the database as an upstream at some port, and then we can update this upstream URI so that the call goes through the proxy and not directly. So here I have a patch that I'm going to apply. It defines the new upstream for the database. This is the port we're going to dial locally to reach it. And now the upstream has us routing the request through that port. Now we're going to apply that patch. And eventually, this address is going to show the request is going via localhost. So this might take a moment for that new service to come up, and there we go. So now the API is going to reach to the database through its local proxy, which then routes it to the terminating gateway, which then forwards the traffic to the database. So now the next thing I want to show is one of the advantages of having everything having a service and its dependencies be in a service mesh are the benefits to observability. So I have this application hooked up in Honeycomb, and right now this, let's see. Okay, cool. So this is currently just showing a heat map of the latencies of my route span. And what I can do now is look specifically at anything related to this database. So now I can filter queries to where the upstream is this database. I can visualize the P99 distribution. And now I can just have more visibility into different portions of the requests that I'm issuing. And here we can see what a span would look like. This is the portion that called it a database. And now when everything is part of the mesh, we can get that full picture of a request from beginning to end. Now, going back to our mesh, we're going to address that second question, which was, how do we accept traffic? And we're going to do that with an Ingress Gateway. The Ingress Gateway configuration is right here. We enable it like the Terminating Gateway, but we also need to define the port that it's going to be listening on for connections to the backend services. I'm going to apply that. And eventually the Ingress Gateway will pop up on the right like it did with the Terminating Gateway. As with the Terminating Gateway, these are configured via configuration entries. We have the kind Ingress Gateway, which tells us the kind of gateway this is the configuration for. For the name, our Ingress Gateway is just going to be registered with a default name, so that's why it's the same. And then for the listener, we're going to spin up a listener on port 8080 for an HTTP service, which is web, and then requests with any host name to that port will be sent to web. In the interest of time, I'm going to go ahead and apply this configuration before the Ingress Gateway is ready. And we're also going to need an intention that allows the gateway to talk to the web service. So I'll make that. And now I need to grab the address. Cool. So now, instead of reaching the web service through its IP address, we're reaching it through the Ingress Gateway. And this really opens up a lot of possibilities. What if, now that we can take advantage of Consul's HTTP routing, we can do things like break off a service from this web front end? And that's exactly what I'm going to do. So I have this service definition for an admin service. It's going to be listening on port 9095, and we're going to inject an Envoy sidecar. Now, I'm going to deploy this, and I want to be able to route requests to this admin API whenever I hit the Ingress Gateway at a specific path. And the way that we can do this is with a service router configuration entry. So we're going to apply it to the service web, and it's going to apply these route rules to incoming HTTP requests. So now, as I mentioned, I want requests that are going to this admin path to route to the admin destination. And for anything that doesn't match that path, I want it to go to the default, which is just web. We can apply that config with that same console config write command. And the result's going to be visible in the UI. So now that I navigate to the web service and the routing tab, I can see that there's two routes here. If I have the admin prefix, we're going to go to the admin service, and everything else is going to go to web. Now, since we have a new admin service, once again, I need to create an intention. And I can now reach the admin service by attaching this pass here. All of it super simple, instantaneous, and we're actually not going to stop here. I mentioned before that an Ingress Gateway can actually route to multiple services from a single port. There's another way that it can do that, and it's via its configuration entry. Let's say that I want to bypass the web service at the gateway level and go straight to the API. So at the same port 8080, I could then define two services, and we're going to distinguish what service to route to based on the host header. So I'm going to write that out. And now, with the address from here, we're going to test that. 1 second. Great. So I'm going to dial the address of the gateway at this port. And actually, I'll show real quick what this looks like in the UI. Now we have these two upstreams. It's going to show you what host name and port you're going to use when addressing them. And I'm going to dial, and oops, we have a connection error. So as I mentioned before, all of this is governed by intentions. So we need to allow the Ingress Gateway to speak to the API. Now we have our API response. When we hit this api.fakeservice.org, and if we were to switch that around to dial web, we have web. And that is the end of the demo. Yeah, let me know if you have any questions. Thank you.